Okay, welcome back to part two. My daughter's iPod had an issue with the over 10-minute video according to YouTube, so we'll pick this up again and get going here. Just tell you about the scroll saw. One's at 6.5 to 7 volts. The power supply is a Variac from another project. I've had all kinds of stuff going. Powers a microwave oven transformer that I cut the secondary off and rewound to give 30 volts AC, and I rectify that and smooth it out into DC voltage. It was to power a CNC router initially, so that's why it's DC voltage. It wouldn't have to be. Okay, back up a little bit. And last but not least, I will show you my monster. This is my large bow that I just built not too long ago. It's got 7 wires on it. And the idea here is each of these is spaced so that it will cut a 1/4 inch slab. And I built this because when I was using my single wire bow, my pieces were starting to warp because the foam is different densities through it. And I was getting a little frustrated. It's got some Delrin plastic slides that slide on this metal track like this. Wires come over. There's a brass bolt at each end, 5/16 by 18 bolt. It's 18 threads per inch. So if you do the math, to get a 1/4 inch you have to go wire every 5th groove, and this bolt acts as a bridge to space the wires, and also acts as a way to get the electricity to the wires. I have them tipped because I wanted the top wire to come out first, and so on and so forth. If the bottom wire comes out first, the whole stack drops and you ruin all your cut. It's not happening because the foam's different density. It's denser in the center, so the center wires are coming out last. So I've adjusted my cut process on the scroll saw to allow for that. A little cheat for that I figured out. Works pretty good. I was pretty tickled how well it worked. So we'll do that then last. Okay, Tanner, once you hit the vacuum bud, we'll take this off since we don't need it. See, there goes another magnet. Have trouble keeping them on. Next ones will be the screw-on ones. We're running about 6 3/4 volts, something like that, where I've been running it lately. And the template is just Formica with a press board, on which masonite backer. I've got holes here. I've hot glued tacks in to help grip the foam. Just sits on like such, and you'll see this on here. See how it slides around? There's just no drag. Heater hole's open at this point, and I usually keep a fan on for the big bow. There's enough air movement here to blow the fumes out of your face. That really hasn't been too much of an issue. We'll start right here. And what's happening is the template is running against the 16th inch tip I turned on the MIG tip, and it's acting as a nice large bearing area. And the MIG tip takes the pressure, the wire doesn't, so the wire doesn't get knocked out of square or bent or bowed or anything like that. So at 6 3/4 volts, this wire is probably pulling 1 3/4 amps, something like that, maybe almost 2 amps. I'll explain what I'm doing here in a little bit with this whole tab process, but It was a cheat that I figured out. I hope you guys can hear me with a shot vac and everything going. Probably should wait to talk till I'm done. Okay. Hey, Tanner. That's what it looks like when it's done. Get a little bit of threads doing it that way because I run a little higher temperature. Look at this. Put that away, bub. Okay. So there it is. Just like that. Just laminate it with Masonite backer board and some tacks. So that's the wing. And I left these tabs here. This is my solution for my 7-wire bow. What's going to happen here? What's going to happen here is, as the wires come through, they form a C shape because you can even see the color difference. It's denser right here in the center, so the wire drags more in the center. And the only way to solve that is run the wires at a different temperature so they all cut the same line, and that's hard to do. But that bow I created because when you run a single wire bow through here, the piece wants to curl, and I was getting tired of that. So the goal here is to cut all the pieces at the same time, and then you get straight flat pieces. But when you get to the end, if the bottom wire comes out before the top or the middle ones do, the whole stack drops. And when that happens, you ruin the rest of the cut of the rest of the wire. So we have a sacrificial tab here on the back side. Nothing special, just something to hold the parts in position until all the wires get out into it. So we'll break this down real quick. You turn the vacuum around, bud. So this just swings out of the way. Disconnect it first. Like that, and that stays right there. I can actually unpin it and take it off if I want.